Here we have a function f of x equals secant x over 1 plus tangent x, and we're asked to find the values of x for which the tangents to f are horizontal. For this solution, we want to clarify what it is that we're seeking, so we'll state that right off at the beginning. We seek x values such that f prime of x equals 0, because f prime of x is the slope of the tangent, and the slope of the tangent is 0 when we have horizontal tangents. So step 1, let's find f prime of x, this function of x that defines the slope of the tangent line. We'll be using the quotient rule here. F prime of x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Let's take those derivatives. It's equal to the bottom 1 plus tan x times the derivative of the top, secant x. The derivative of secant is secant times tangent minus the top, secant x, times the derivative of the bottom, which is 0 plus secant squared x, over the bottom squared. Now continue simplifying this, and we get 1 plus tan x times secant x tan x minus secant cubed x over 1 plus tan x squared. And that simplifies further to secant x tan x plus secant x tan squared x minus secant cubed x. See, I just distributed the multiplication on top over the denominator squared was 1 plus tan x squared in parentheses on the bottom. Now we're going to factor out the secant in the numerator. Just to clean it up, we've got secant parenthesis in the numerator tangent x plus tan squared x minus secant squared x over the denominator 1 plus tan x squared. Now at this point we'll just clean it up with a trig identity, the one that says 1 plus tan squared theta equals secant squared theta. By the way, the trig identities are located in the back of your calculus text. So that's equal to secant x times parenthesis tan x minus 1 over 1 plus tan x parenthesis squared. There you go. That is f prime of x. That is the function that represents the slope of the tangent. So step 2, we're going to find the values of x for which this slope is equal to 0. In other words, where the values of x where f prime of x is equal to 0. So we'll set this function f prime of x equal to 0. So we have secant parenthesis tan x minus 1 over parenthesis 1 plus tan x squared. Set that equal to 0 and solve for x. Well, for a fraction to be equal to 0, that implies the numerator must be equal to 0. That's the only way a fraction can be 0. So our numerator, secant x times tan x minus 1, has to be equal to 0. All right, we'll break these factors down. That's secant x equals 0 or tan x minus 1 equals 0. Well, if you look at the graphs that I have written here, secant is never going to equal 0. So there's no solution to secant x equals 0. So that doesn't give us any information here. We're looking for the x values that make this guy 0. That one didn't give us anything. So the tan x minus 1 equals 0. That means tan x has to equal 1. We'll look at the graph. Tan equals 1 when x is equal to integer multiples of pi plus pi over 4. You see in the picture, I found the value 1 for the tangent value, and I put a dotted line horizontally across, and I circled a bunch of those x values, or a bunch of the locations on the graph where the tangent is going to be equal to 1. And if you look down at every one of those circled points, you're going to find that their x coordinates fit the description of x equals n pi plus pi over 4 for some integer n. And there's infinitely many of those.